Hello everyone, welcome to the channel Otakutronics, and today we are going to study the OR gate using the diode circuit. So before we get started, I want you to understand this basic thing that what logic 0 means and what logic 1 means. Okay, so logic 0 in a circuit actually means that it is the lowest voltage of the system. Okay, so logic 0 means it is the lowest voltage of the system. And what does logic 1 means? Definitely it's the opposite. If this logic 0 right here is the lowest voltage of the system, then logic 1, here we go, logic 1 would be the highest voltage of the system. So let's write it down here. Logic 1 means the highest voltage of the system. Now in the case of OR gate, let's draw two voltage points. We're going to use two diodes. So I'm just going to draw this right here. Make three columns right here. Okay. A, B, and B naught. Now here, in this case, we are going to use a circuit that has two diodes, diode A and diode B. And in this case, we are going to have four different variations. We are going to have four possible combinations. And how do we figure out how many possible combinations there could be in a circuit? It's very simple. We are going to use this little formula 2 exponent n. And let's suppose you have two diodes, so you are going to input 2 exponent 2, which means four possible connections. Now let's suppose you have three diodes A, B, C. So what you're going to do, you're going to put 2 exponent 3, because it's going to be like 2, 3. You're going to put n equals to 3, n equals to the number of diodes, and this would just turn out to be 8 possible combinations. Similarly, if you have 4 diodes, you're going to put 4, and then it's going to be 16 possible connections or combinations. So we are going to do understand the OR gate using the diode circuit, and we are going to make the basic diode circuit using only two diodes, which I will name as A and B. And using only two diodes, we have figured out that there are going to be 4 possible combinations. So I'm just going to make 4 rows. Now in the 4 possible combinations, the first combination will be that both of the diodes are off. Now you can also try to realize that here you can see that logic 0 refers to the lowest voltage of the system. So we are going to take the case where both of the diodes are off, means both of the diodes are at the lowest voltage of the system. Then there is going to be a case when one of them is at the lowest and the other is on the highest. And then again the opposite, one of them is going to be at the highest and the other is going to be at the lowest. And then when both of them are at the highest voltage of the system. And you're going to figure out how the OR gate works. We're going to actually solve the circuit and figure out what is the output voltage. So I'm just going to make a simple diode circuit here. Let's say this. Okay. This is a 1 kilo ohm resistor, and this is ground, and this is the output voltage. Let's name this as A. Let's name this as B. Okay. And this is diode 1, this is diode 2. Both of them, let's consider both of them as silicon diodes. In case you don't know, silicon diode has a drop voltage of 0.7 volts. Okay, in case you don't know. Now how do you solve this circuit? Let me tell you. For case 1, let's suppose that A is 0 volts and B is also 0 volts. In this case, we can see that the diode is supplied with 0 volts, and so it will be turned off. Or in diode 2 as well, we can see that it is going to be supplied with 0 volts, which means the diode would be off again. And also, if you look at with a different perspective, both of the diodes have the same potential across them, like 0 volts here, 0 volts at the other terminal. Again here, 0 volts at this terminal, 0 volts at this terminal. So when the same potential exists across a diode, which means like this, if I say there's a diode and there are 10 volts here, 10 volts here, then in this case as well, the diode will be switched off. And when the diode is turned off, it's an open circuit. So if I redraw the circuit, let's say that this diode is off, it will be an open circuit and no current would pass by. Okay, so the current would be 0. And in this case, both of the diodes are turned off, so the current would across both of them would be 0. There won't be any current in the circuit at all. So now we are going to find out V0, the output voltage in the first case. And if you use your common sense, the output voltage would also be 0. But let's say use the Ohm's law formula, which would say that V naught minus 0 I into R. And in the first case, we can see the current is 0 again, multiplied by 1 kilo ohms, and the answer would be 0. So this is the first case when both of the diodes are turned off, or both of them are at logic 0, lowest voltage of the system. So it would simply be 0 again. Now for the second case, we can see that at A, we have 0 volts, or I shall say the lowest voltage of the system. And let's suppose the highest voltage, let's suppose a voltage of 10 volts in the circuit. Okay, let's suppose. We are supposing the highest voltage of the circuit is 10 volts. We are going to provide B with 10 volts and A with 0 volts, the lowest voltage and the highest voltage. Now at this, at diode 1, we can see that same potential exists, 0 volts, 0 volts. This diode would be turned off. So there is no current passing through this diode. But when we look at diode 2, at the silicon diode, we can see that there's 10 volt and there's 0 volt, which means the diode is on and it's forward biased. Now in this case, we are going to replace it with a voltage drop like this, and we're going to write 0.7 drop here. So now how do you solve this? So we have to find out output voltage at this point, V naught, and what we are going to do simply is that we are going to subtract the drop from the supply voltage, which is directly connected with the output voltage. So if 10 volts are being applied and 0.07 gets dropped, what is the output voltage? So we are just going to subtract 0.7 drop from the 10 volts, and it gives V naught. Now if you're an electronics engineering student, you can also apply KVL or KCL at this point, but if using your common sense, you can see that this is the supply voltage, something would be dropped here, and then this would be the output voltage. So we're going to subtract 0.7 from 10, and we're going to get V naught equals to 9.3 volts. Now in this case, 9.3 volts, what do you think? Is it close to logic 0 or is it close to logic 1? Now if you look at this, logic 0 means the lowest voltage of the system, which is actually 0 volts, and logic 1 means the highest voltage of the system, which is 10 volts. And you can see that you can round off this 9.3 to 10 volts, right? So in this case, the logic A is 0, logic B is 1, and at the output we are getting approximately 10, which is high, which means it is logic 1. So we're going to write 1 here. Okay. Now similarly in the third case, we are also going to get a 1 because we're going to switch this off. We're going to provide 0 volts at point B, we are going to provide 10 volts at point A, and in this case the diode 2 will be switched off and diode 1 will be on and forward biased. And in this case we are again going to get a drop of 0.7 because it is a silicon diode, and because it's 0.7, we can subtract 0.7 from 10 volts, and again we are going to get 9.3 volts. So even in the third case, when we apply KVL at this node, we are again going to get 10 volts minus 0.7, which is drop, is equals to V naught, which is again equal to 9.3 volts. And this 9.3 volts would be rounded off to 10 volts, which refers to logic 1, right? So in this case, we are again going to get a logic 1. And let's take a look lastly at the last combination, which is when both of these terminals are at high. So in this case, we are going to provide 10 volts at both terminals, which is the highest voltage of the system. And we can take a look at this. If we take a look at diode 1, we can see that it's 10 volt and 0 volt, which means the diode is on. And if we take a look at the B, we can see that 10 volts and 0 volts, which means this is on as well. Now we can either calculate V naught with the help of diode 1, like in case 3rd, or we can find out V naught with the help of diode 2, like in the case 2. But here I am simply, what I'm going to do is that using both. In first case, like in this case, in the last case, we're going to take diode 1. So if we take diode 1, it's just simply 10 minus 0.7, and again it's 9.3. And if we take diode B, it's again 10 minus 0.7, which is again 9.3, which also rounds off to 10 volts, which means it's logic 1. So even in the last case, we get logic 1. So this simple circuit, the simple diode circuit, tells you that in OR gate, if both of them are true, it's true. If either one of them is true, which means if either one of them has logic 1, the output would also have logic 1. But if both of them are logic 0, meaning the lowest voltage of the system, definitely the output voltage would be 0, which means again the logic 0. So that's all for today. Thank you for watching the video.